How do you explore oceans that are pitch black, have skull-crushing pressure, and cover about 70% of our planet? Well, currently it's a massive challenge, and we've only discovered about a quarter of it. So let's talk about being left in the dark, because I'm seeing a real problem here. For decades, we've relied on massive ships or tethered robots to do the heavy lifting. However, today I'm going to be talking about a tool that's been making a huge splash in our progress of ocean discovery, the Autonomous Underwater Vehicle, or AUV. While other tools and resources do have their place, my research suggests that AUVs are the best vehicle for marine research. They give us better data, better access, and do it all without drowning a project's budget out. So what exactly is an AUV? Think of it as a self-driving car, but for the ocean. It's a robot that is completely untethered and entirely pre-programmed. You give it a mission, drop it into the water, and it does all the work on its own with no strings attached. Literally. Compare that to an ROV, which is a remotely operated vehicle. Now, they're great and all, but they're limited by their tether, which is attached to a ship through a long cable. So this supplies power and sending commands where a human pilot is constantly driving them. Talk about being under peer pressure. And then there are research vessels, or RVs. These are huge ships that are on the surface that ROVs are attached to and AUVs are deployed from. They use sonar to scan the bottom but are severely limited as they can't actually go underwater, which I hate to be shallow, but they really just scratch the surface. So why is an AUV the real winner here? Let's dive into the costs. Running a massive research vessel requires a crew, fuel, and plenty of supplies. It's a whale of a lot of work and makes it really easy to sink your expenses. In fact, studies have shown that the purchasing price of an AUV is about 1/20th of that of an RV. That's even better than the daily running costs, which are about 1/50th of the entire ship. That means for the price of one mission on a ship, you could run dozens and dozens of missions with an AUV. That level of efficiency is what keeps scientific projects and plenty of researchers afloat, even on tight budgets. But it's not just about the money. What's more important is the quality of the data. Ships are loud, really loud. Their engines create noise that scare away fish and marine life, which can heavily skew the data. And I'm not sure about you, but that sounds really fishy to me. On the other hand, autonomous underwater vehicles are virtually silent. They glide through the water with a low noise profile. This allows for better conduction of marine life surveys, as they are able to get closer to sea life without disturbing the environment. They can also reach places ships and ROVs simply can't. AUVs can dive deep to avoid dead zones near the surface, and be utilized to travel underneath ice sheets in the Antarctic that ships are unable to break through. Now, I'm not saying that we should abandon all RVs, ROVs, and other sorts of research vessels. They still play a vital supportive role. If you need to grab a quick sample, using an ROV with live video footage is amazing for that. And having a robotic arm is a great resource to have when you're able to directly interact and move it. And obviously, we need the ships to carry the AUVs and the RVs and ourselves out to sea. But for the heavy lifting, scanning, and long-term monitoring, AUVs are just the perfect star of this show. They are 100% the current leader in current marine technology. So this technology isn't just theoretical to me, I'm completely immersed in it. I'm a mechanical engineering student and part of the underwater robotics team here at Ohio State. And as a member on our mechanical team, I work on our robot Talos. Utilizing computer-aided design and CAD software such as SolidWorks or Onshape, we are able to 3D print all of our designs, bring them fully to life, and make sure our vehicle doesn't crack under pressure. Recently, I designed a modular rail system for this robot. The goal was to make maintenance easier, allowing us to remove critical electronics without the use of heavy machinery and constant reassembly. At the end of the day, my primary goal was to streamline the process of maintenance. We tested it through 4 design iterations, including leak sensors and using heat inserts. The result? We reduced our whole disassembly time by over 50%, and that efficiency exactly mirrors why I love AUVs so much. Ultimately, the shift from massive ships to agile, autonomous robots represents a huge change in how we now explore our planet. We are moving away from just skimming the surface and finally getting to the bottom of things, literally. AUVs are quieter, cheaper, and can reach deeper than we ever thought was possible. They're the key to unlocking over 80% of our ocean that we have yet to see, and I'm overjoyed to be a part of that future. I hope you enjoyed this deep dive and learned a thing or two. Thanks for watching.